Lesson 5.5, Proving Triangles Congruent by SSS. Essential question, can I use SSS and HL to prove triangles are congruent? Our theorem is SSS congruence theorem, and we are going to show that when you have three sides of one triangle congruent to three sides of another, that's enough to ensure rigid motion, and these figures will map onto each other. Here's how the proof goes. What we're going to do is we're going to go through some rigid motion, and we'll first do a translation to get point A to map onto D like this. Then we're going to do a rotation, which is shown right here, and we're going to get the figure to look like this. Now, as soon as it looks like this, I'm going to draw a line from point E to point B double prime. And you're going to have two isosceles triangles. You're going to have a triangle right here, and you're going to have an isosceles triangle right here. Now, you remember that if two sides of a triangle are congruent, then the angles opposite are congruent. So this angle is congruent to this angle, and this angle is congruent to this angle. Now, if you add these two angles together, it'll be the same as these two angles together. So angle DEF will be congruent to angle DB double prime F. So we're going to get this whole angle here to be congruent to this whole angle here, which will force these two triangles to be congruent by SAS, because they have a pair of sides, a pair of angles, and a pair of sides. And we know side angle side does have rigid motion to map onto it. So we know that this triangle will be congruent to this triangle by SAS. All right, let's take a look at a proof in which we use SAS. So here's our plan SSS. Now you can see that we have a given, and that's going to be an S side. And you can see that our other given is another S side, and they have this side that they share, which we call the reflexive property. And we now have the other S, so we can say the triangles are congruent to each other by SSS. All right, decide whether the congruent statement is true. Explain your reasoning. Okay, you can see that we have a pair of sides, another pair of sides with 2 tick marks, another pair of sides with 3 tick marks, and let's see if we have that letter order in the right order. Okay, D is between the 1 and the 2 tick mark, H is between the 1 and the 2 tick mark, F is between the 2 and the 3, J is between the 2 and the 3, so the letters are in the right order, so the answer is yes. Let's go ahead and take a look at this. We notice that I have a pair of sides that are reflexive, so I have an S. I have a pair of sides that have 7, and that's another S, but unfortunately this 3 and this 4 are not congruent, so the answer is no. All right, let's take a look at this. We have a pair of sides with 1 tick mark, that's S. A pair of sides with 2 tick mark, that's S. A pair of sides with 3 tick marks, that's S. Just let's go ahead and check to see if the letter order is correct. Q is between 1 and 2 tick mark, and it goes with R, which is between 1 and 2 tick mark. P is between 2 and 3 tick mark. S is between 2 and 3. So it looks like the letter order is correct, so we say yes. Okay, let's go through a proof here, and this is going to be showing the SSS as well. So you can see in your given right here, we already have a pair of sides. Now this is not a pair of sides, although it's telling us that this is cutting BC in half. So we know that these two will be congruent to each other, and that comes from the definition of segment bisector. I got this idea from this word bisects, and it's bisecting a segment right here. So that's what gave me the idea. And this is another S, and then they share some sides in common, so that's reflexive. That's an S. And so now we've met the requirement, and that's going to be SSS. Okay, you know that SAS and SSS are valid methods. What about SSA? And so here they're saying SSA is not a valid method, and this is a demonstration on how to do it. This is a counterexample. Notice you have side, side, angle. And notice over here you have a side, side, angle. But unfortunately, this angle right here is not the same size as this out here. You can think about this as kind of a hinge right here, where this swings out over to here to touch the bottom right here. So it's like a hinge that goes from here to here. So there's not an SSA. And that a lot of that is because this angle right here is an acute angle. So it's allowing it to swing back and forth. What happens if that angle is not allowed to swing and we make it a right angle right here? If we make it a right angle, then this side doesn't have that opportunity to swing and it stays right put. Now this is called the hypotenuse leg congruence theorem. And we use the word hypotenuse and leg when we're working with a right triangle. And we have to have this right angle in order for that to work. All right, let's take a look at a proof that shows how to use HL. So this is HL. Now the picture at first was rather complicated. This was the original picture. And this symbol means perpendicular. And so this is a right angle right here. And this is a right angle right here. And what we're going to do is we're going to take these two triangles and we're going to split them up, write them separately. So this is WZY right here, WZY. And then over here this is XYZ. I just kind of drew it over on the other side so you can see this. Now notice that right here we're being given some congruent pieces. WY is congruent to XC, and it's easier to put it in this picture than the original when it was intersecting. Now this is a hypotenuse pair, and so in the given they're giving us this hypotenuse pair. So I'm going to put an H here because I got a hypotenuse pair, and I've got some perpendicular, and perpendicular always leads to right angles. So this comes from definition of perpendicular. This perpendicular gave me the idea that I had right angles. Now if you have a right angle, then you have right triangles. Definition of right triangle. So we know that we have right angles, and HL requires that you show right triangles. Okay, so now you can see that ZY is a reflexive side. So this is the same letters, and that's a reflexive. We like to put X's on reflexive, so this is reflexive. So these are the three things you need to show me. You need to show me an H pair, which the given was. You need to show me the L pair, which was a reflexive. And you need to show me that you have right triangles. You don't have to show me the right angles are congruent. You have to show me you have right triangles. So this is our right triangle, and this is our L here. So we have everything here. So we can say HL. All right, let's take a look at this picture. You can see these are two right triangles, and it says redraw. So I'm going to take this drawing right here, and I'm going to redraw it so it looks like it's facing the same direction. And here I'm going to put a right angle here, and that's the letter B. And then this long part, I'm going to put a C. And then this must be the short part, which is A. So I took this triangle and I have redrawn it over here. So these triangles look the same. Okay, and you can see by the given, we already have a pair of hypotenuse and we have a right angle. So let's see if we can go ahead and write the theorem. Remember, this is HL, and you have to show me right triangle. So there's three things you got to show me. Number one, we were given that angle B and, oh, I shouldn't say angle B, I should use three letters. Angle ABC and angle BCD are right angles. And I also was given that AC is congruent to BD. Right here. AC is congruent to BD. And that's going to be a hypotenuse. And so this is the given. All right, so I have the hypotenuse here. Now 2, you can see that they're sharing this BC. So BC is being shared by both of them. So I'm going to say BC is congruent to BC. That's going to be a leg, and that's going to be reflexive. Okay, so I have the L. Now the last thing to show is that I have right triangles. So I can say triangle ABC and triangle DCB are right triangles, and that's because of definition of right triangle. As long as you have a right angle in it, you have a right triangle. And now I have the right triangles, and the last step is to say the triangles are congruent, and I'm going to use HL. And that's the end of the screencast.